All right, let's welcome our next group. We have Xavier, Haley, and Blake.
All right, so we had equals. So why is the equals important? Well, the equals is essential part of the ALU, the arithmetic logic unit. Without basically the ALU within the computer is almost useless for the fact that it performs all the calculations and arithmetic within the computer. The ALU is responsible for things like the logic operations such as the AND and the OR gate, and also inverters, multiplexers, so on and so forth. How the equals tie into that, because what the equal does is it receives an input from the ALU and gives the value from the comparison flag.
Okay, so the ALU receives two 64-bit inputs, and the control ROM, and it receives the control ROM 1-bit opcode. And if it's 1, then it does a compare and sends that to the comparison flag.
As you can see, this is our ALU, and we receive our 64-bit inputs from the register file and through the MUX, which is also connected to the register file. And we receive our 1-bit opcode from the control ROM right here. And even though it's not shown in this, there's like an imaginary box where the compare flag is stored. Next slide, please. These are the test cases that I ran. I'm sorry that I do not have a PowerPoint, but I think for ease of visibility, you can actually see these,
yes.
which is rather neat. These are the 3 test cases that I ran personally, which we're only looking for the most minute, change that gives us a different result. So for that one, first one, we're comparing 0, 1, 1, 0 and 0, 0, 1, 0, which, because they're not the same, gives us 0.
F5.
Nice. Next one is 0, 1, 0, 0 compared to 0, 1, 1, 0, which again is different, which gives us a result of 0. The last one that I used, they're both the same, so it gives us a result of 1.
Just explain why you chose these ones.
The reason I chose these ones is because it's only a small and very minor difference, and it will allow me to test if it's like some discrepancy between either of them having 1 or both of them. Like,
or simply put, you wanted to test it
Yeah.
one that were equal and ones that were not.
Yeah, I would just want to
Make
test
sure
that they
it's
were
working.
equal, and the reason I just did 2 is so that I could test if it's like
Now,
some individual error.
this is Verilog. It's 64 bits, but I only have 4 bits here. Did the actual test use 64 bits?
The 64 apostrophe B automatically extends it
Well, extend it all.
with multiple zeros, so I don't have to manually type out 60 other zeros into the test case.
Alright.
All it puts in is the last 4 values. Next slide, please. To avoid spoiling what gates we actually used, we calculated out that the total gate delay of it is 6.
Well, you
Assuming
can tell us
maximum
what
gate delay.
gates you used. Just don't give us the code.
Oh, well, the gates we used were the XNOR gate and one very massive AND gate. The reason it's very massive, as I explained here, is that I individually received every output from the XNOR gates and sent them all through a singular AND gate, which made it a massive pain to code. But aside from that, it ran fairly well. There were no mechanical issues aside from it taking probably about 20 minutes. Other than that, it's a rather simple code and very easily implemented. And that is the end of our PowerPoint presentation.
At the end, you ask the questions, because we're supposed to do questions, little Q&A. So yes, any questions? You elected yourself, Perry.
I know. I'm trying to think.
Here's an idea. How about don't? You wanna help him out, Sam?
So how did you make this PowerPoint?
Well, we used the Google Drive and we shared it between all of us, and then we downloaded it as a PowerPoint.
There we go.
Very effective. Alright, so let's go back to the architecture diagrams.
Just back to slide.
Right there, yeah, perfect. So, maybe I didn't explain it perfectly in class. The ALU is always going to output if the two inputs are equal. So it's not based on the opcode. The opcode just says whether the ALU is going to do an AND or an AND or an add. It's always going to do the comparison in parallel and have that little flag go out, because that flag is always going to like a CMP flag if it's the correct.
Okay, so it's a conditional that says if
Yeah.
if this is 1, then you're going to use this one.
Yeah,
This
yeah.
is the output, or if it's
Right. So
Okay.
just so you know, for implementations, you don't need to use the opcode coming in for compare. You just always spit that out.
Okay.
Yeah. I think that's about it. Anyone else? Okay, great. Good job.
Thank you.